This video is titled Variables in IMPRINT. In this video segment, we will cover how to create variables, how to implement them in effects, as well as how to implement them in path logic. To begin with, whenever you start adding new additions to your model, it's always a good idea to create a separate version. This is especially true when you start dealing with C# code and variables, because it's very easy for you to make mistakes that might break your model, and it would be much to your advantage to have earlier versions of the model available to go back to in case you aren't able to undo or correct whatever items you've implemented. So to create a new version of your model, what you do is you right mouse click on the current mission, and you can say copy mission, and then hovering over the operations model section, you can right mouse click and hit paste mission. This will create a new version of your model, so you've got both the old version and the new version. When you create a new version, it's always a good idea to go back and to update what you currently have in your model. So we now actually have our full task network, and we've added, in this particular version, we plan to add the variables and decision logic. All right, we'll go back to our network diagram now. Sometimes when you open up a new version of IMPRINT, you'll see what looks like task connections flowing around and nowhere. They are connected still. You can grab hold of where they're coming out of or where they're going to, and just move it around a little bit and they'll snap back in place. Hopefully that's something that will be corrected in future version of IMPRINT. You'll also notice that sometimes your connections just relocate themselves, and so if you're particular about that, you may want to spend a second just cleaning up some of those path flows so that they're easier to see. All right. So in this particular model, we have a user interfacing with an ATM, and what we want to capture is that here in this area, the person is entering their PIN, and then the system authorizes the PIN. And we're going to give the person 3 tries to try to enter their PIN correctly. And if they are not able to enter their PIN correctly, at that time, it will eject their card from the system. So in order to do this, we're going to need some variables. We're going to want a variable that captures how many times the PIN has been already entered. And we're also going to want a variable that captures whether or not the current version of the PIN that's recently been entered is correct or not. So in order to create variables in IMPRINT, you're going to use the variables module, which is in your analysis tree on the left-hand side. You can expand the variables module and find out that the clock variable is already included. This clock is the simulation clock, so it references the current simulated time in the model. And oftentimes you may want to insert logic that references that clock time. We're going to go ahead and add our 2 new variables. So to do that, we are going to right mouse click on the word variables and then select new variable, which creates a new variable called variable. We can then double click on that, and that opens up the dialog box for that particular variable. We can update the variable's name, so this is going to be the number of PIN entries, right, or number of times the person has entered the PIN. What you might want to do is also include a description. It may also be valuable for you to go back into this description after you have implemented code in your model in order to indicate which task nodes are using that particular variable. You can also specify the variable type. As you see here, we have Boolean, floating points, integers, objects, strings, and hashtags. In our case, the number of PIN entries is an integer because it is going to be in even increments 0, 1, 2, 3, 4, and so on. Well, they won't get a 4th try. You can, if you did have a variable that's an array, you can indicate that it's an array and specify the dimensions of that array. And you know that you can also indicate your initial value. Of course, when the person first enters the system, they have not yet entered their PIN, so we will start with an initial value of 0. So now that we've created this variable, we want to go ahead and indicate where in the model we're going to use this variable. So I'm going to go back to the network diagram. And in order to capture when the PIN has been entered, we're going to use the effects. So we're going to go into the Enter PIN task node. And you'll see the second tab is called Effects. And there are 3 types of effects. There are release conditions, beginning effects, and ending effects. Release conditions occur at the start of the task, and they're actually the criteria on whether or not to start the task. So an entity will not start the task if the release condition criteria is currently false, but that will be checked every time a new event occurs in the model. And so if in a future event triggers an effect that causes the criteria to become true, then your entity will be released and start the task at that time. The beginning effects are after the release conditions have already occurred, and these beginning effects capture any kind of conditions or changes that you want to occur before the start of that task. And then the ending effects occur at the end of that task. So we want the person to enter the PIN, and then at the very end of that task, we want to indicate that the person has entered the PIN one time. So to do this, we will go ahead and type in the relevant C# code. This will increment our number of PIN entries by 1. As you can see, when you've done something incorrectly, it will actually give you a little bit of a red squiggle there underneath the particular code where it thinks that you've made an error. So that can help you in finding errors in your code. Right, so every time the person enters their PIN, an ending effect will be to increment that up. So if we go back to our network diagram, the first time that goes through, it'll change from 0 to 1. The second time it goes through, it'll change from 1 to 2, then 2 to 3, and so on. In addition to capturing the number of PIN entries, we also need another variable to capture whether or not the PIN is correct. So we're going to create a Boolean variable. We'll go back to our variables and right-click and hit New Variable. We'll double-click on that variable and we'll call it PIN correct. And in this case, we're going to capture somewhere else in the model that the probability of the person entering the PIN correct is 98%. Well, let's do 95% since we've got the number 98 somewhere else in the model already. We don't want to confuse those two. 5%, and we'll indicate where it's used. All right, so this is a Boolean variable, which means it can either be true or false. And once you select out of that, you'll see that the initial value updates to false. So that's what it starts off on, and we're actually good with that. So it's going to start with the assumption that the PIN is incorrect, and then we have to actively update it in order to set the PIN to be correct. So we'll set logic later on that actually triggers whether or not that's true or false. I actually like to start off with just keeping that a specific value so that I can test the other parts of the code in my model. So we can now use these two variables as path logic. We go back to our network diagram. So we've got right now that when they enter the PIN, we've got an update on the number of PIN entries. As an ending effect, we also are going to go ahead and set the value for that PIN correct variable. And make sure that when you do create your variables, you don't put any spaces in. That's one thing that IMPRINT does not allow. So it's already set to false. Right now, we're actually just going to keep it at false, and as you can see, the IntelliSense code came on, so it recognized that I was typing some code, and it's giving me some options here. You can see that there's a red squiggle there indicating that I don't yet have my semicolon. Like I said before, IMPRINT does use C#, so if you have any questions about the format and the syntax for your code, you can go to any C# reference manual, and hopefully it will be helpful to you. If you're still struggling, feel free to contact the IMPRINT team via the SharePoint site. So now, after they've entered the PIN, the system is going to update the number of PIN entries, and it's going to set the value of whether or not the PIN is correct. We're going to keep it at false for now, and then we'll switch that up in a minute. So now we move on to the authorized PIN. And what we want to happen is, here in the path logic, we don't want it to do all three of these. We want it to do one of these three. So we're going to switch this to a tactical path. And with the tactical path, we want to have it, if the PIN is actually correct, then we want it to go from this authorized PIN node to the enter amount to withdraw. So I'll start off by going ahead and just writing the comment of what I want to happen. It's a good idea to start off commenting so that you make sure you got all of your logic correct. All right, if the PIN is not correct, but they have done less than 3 entries of their PIN, then we're going to allow them to re-enter their PIN. And of course, if the PIN is incorrect and they have done 3 entries already, then we're going to eject the card. So to do this, we're going to actually use if-then statements, because there are certain cases when each of these is true and other cases when it is false. All right, and make sure that when you're checking a Boolean value, or if you're checking any value, that you use the double equal sign to check it, because of course a single equal sign will actually change the current value that's being stored. Okay, so we now have our logic for all 3 of these paths, and one of the things that it's a good idea to do is that when you're using tactical paths, you want to make sure that all the criteria are mutually exclusive. So you want to make sure that it's not possible for multiple one of these to be true at the same time. Because of course, if they are true, given that's a tactical path, it's not going to proceed down both, it's only going to proceed down one, and it may not be the one that you've intended. So if you do intend to proceed down multiple paths simultaneously, you should use the multiple decision type, right, rather than the tactical decision type. All right, so we now have this here. Once you've entered a good amount of code, it's always a good idea to check and make sure everything is working correctly. So if you go up to the top, there's a check mark that says check for errors. I do believe that's also under execution. Yes, it is. And I guess you have some keyboard shortcuts as well. So we can check for errors. In the output tab up on the screen, you'll see that it says the check is beginning, code generation complete, no errors found. That's great. We can go ahead and insert an error here and then do the check again. And we'll see that we get some information explaining about the error. So it says it's happening in the authorized PIN node, which is true. And then it's telling us that it's happening at the path where the authorized PIN is trying to eject the ATM card, which is also true, authorized PIN eject ATM card. So it can help you, it's kind of near this return true portion. It can help you try to find where your code errors are by running that. It's a good idea, like I said, to check often. What you don't want to do is enter a super large amount of code, and then when you run this check for errors, you have 20 or 30 different errors that you have to scroll through and fix individually. So I'm going to go ahead and save the model because it's been a little while since I've saved. And now I'm going to return to the network diagram. So right now we have it set to be false, which means it should loop around all 3 times, and then on that 4th time it should go up and eject the card. So I want to test and make sure that that logic is working as intended. To do that, I'm going to use the step simulation tool. So you can click on it, and once you click on it the first time, you'll see it says that the simulation's beginning. Click on it again, not much is happening. All right, so we click on it again, and now we see a little 1 up here, so we know one entity has been created here at the model start. I'm going to click through, it left that one, and it went to the insert ATM card. Click through again, we're now validating the ATM card. I do have a 98% probability of being valid, so hopefully that one picks it up, and this isn't one of the 2% times. Okay, good, it is one of the 98%. We're now on to enter PIN, so they're going to enter the PIN, and we know it's going to set that to being false, and it should set our counter to 1. So I'm actually going to go down here to the variable logic. It's probably too late, but number of PIN entries. So I don't have it now, but I'll have it for next time. And then we'll go through, and now you see it was false, so it went back to enter PIN. We can now see here at the number of PIN entries, it's been 1 already. When it leaves, it'll now be 2. So we've now entered the PIN twice, and go through. We're here to enter PIN, and when it leaves, it goes to authorized PIN. We're now at 3 PIN entries. And at this point, since it's been 3, it shouldn't allow us to do a 4th. Instead, it should eject the card. So we'll step again, and there it goes to eject the card, and we'll let it carry through. If you're testing something at the very beginning of a model, you can go ahead and just run however far you want, and then just hit the halt simulation to stop, so you don't have to click through 5,000 clicks in order to finish out the rest of the model if you're just testing something at the beginning. If you're testing some code at the middle or the end, you can use a model.pause code, and you can use that using the clock time. So you can set an if-then statement at one of the tasks where maybe you want that as a beginning effect. You could just do a model.pause, or you can do a time-based model.pause, and that particular code will allow you to go through, and you can actually run the simulation in full, and it will go all the way to the pause point, and it'll pause, and then at that point you could pick up with the step simulation to step through and test your code. All right, great. So we know that the false part works. But now we want to capture, we don't want it to always be that the PIN is incorrect. We do want to capture that 95% of the time the PIN is actually correct. So I'm going to go back into this enter PIN, and I'm going to change up this code here so that it doesn't just automatically set it's a false. And because I want this to be probabilistic, I'm going to do this by setting up a local variable that is a random number between 0 and 1. All right. So we do that using the model.random. So we've got a local variable. It's not being stored globally, so it's only going to be used in this effect, and then it's going to disappear from the model. We're going to call that variable random, how original, right? And then this variable that's called random is going to generate a number between 0 and 1 and store it. So it's a uniform distribution. And then we're going to have it check. And what we want to do is 95% of the time, we want this particular variable to give us a PIN correct equals true. And then what we want is we want that last 5% of time. So the cases where the random number is not less than 95% for it to equal false. All right, and we'll go back to our output window here for a second and we'll check this. No errors found. We'll go to our variable watch. In addition to the number of pin entries, we'll also follow this pin correct and see what value it's storing. So we'll go ahead and step through this simulation now. So we're at validate ATM card, enter pin. All right, it looks like this is true, 95% time, so that's expected. And then since it's true, we now see that the entity is proceeding on. So we know that it did correctly evaluate and update that particular item. If you wanted to test it out a little bit more, you might want to set the value to be 50-50, so that way you could run the model a few times and see the different values. In fact, we could go ahead and do that. So we could make it a 50% chance and see, we'll halt the simulation so that we can go ahead and step through it again. Let's see. Oh, we still got a true. Okay, so let's try making it a 25% chance. Alright, so we'll make it a 25% chance and we'll run it through again. You can also use different random number seeds, which we'll get to in model execution. Alright, that time it did pick up a false, 25%, so we're kind of expecting that. And then we'll go through and picked up a false again because we're still at 25%. And the third time, oh, we got 3 falses in a row. Alright, so should you check the card? So we're seeing that it is picking up both the ability to change true and false, and you could run it a number of times and actually make sure that your items are working correctly. Let's go ahead and change it back to 95%. And we may want to go ahead and add some codes here, code comments here as well, right? So if you need help with your C# code, you can go to the IMPRINT Pro Volume 3 of the User Guide, Chapter 2. That's stored in your programs. If you go into IMPRINT, you'll see that under Documentation there are user guides. So you could go into Volume 3, which is the syntax reference, and that will provide you with some example C# code that's commonly used in IMPRINT. You can also try Googling the C# code that you're trying to find on the internet. Sometimes it's helpful, sometimes it's not. As you can see, we're only really doing code snippets here. We're not building full programs. So sometimes you get more code than is needed when you Google, but that's always an option for you. And of course, if you're really struggling with the code and things are not working out correctly, you can always contact the Allian IMPRINT help desk through the SharePoint site. So in this particular video segment, we covered variables and how to create variables. We also covered the different types of effects, release conditions, beginning effects, and ending effects, and also showed how to use variables in order to implement tactical path decision logic.